In the last part of our discussion on cross-validation, we shall see how to use cross-validation to choose value of a tuning parameter. Generally, the choice of tuning parameter is already built into most statistical packages using cross-validation, so you really do not have to do this cross-validation. The thing that we did, it is already done internally. That is why I will not show you any art session for this part, but I will just discuss how it is done. Say I will take as an example ridge regression. I do not know whether you already know ridge regression or not. Basically the idea is this. It is again a linear model setup, y equal to x beta plus epsilon. Now in this linear model setup, we know that the least square estimate is given by this. X transpose X inverse X transpose Y. I will assume that X is full column rank and so this inverse exists. Now it sometimes happens that while this is non-singular, it is pretty close to being singular. Its determinant is very close to 0, and when I divide by the determinant to compute this inverse, it leads to various numerical instabilities, and even if you use other methods like Householder transform to avoid computing the inverse, still this is not a very good estimator. Then we use ridge regression, which is defined like this: x prime x plus lambda I inverse x transpose y, where lambda is something greater than 0. So this is something like a heuristics. Well, this was not this was very close to being singular, so its smallest eigenvalue was very close to 0. Just push everything by some amount lambda so that it moves away from 0. So that was the heuristics. This lambda is a tuning parameter. The question is, how would you choose lambda? So that is your tuning parameter. And how to choose the tuning parameter value. Now the way to choose tuning parameter value, as I said, it is already built into the function lm.reach, which you can find in package mass. So no need to really implement whatever I am going to say, but I'll just tell you how to do it. You pick a number of values for lambda. So these are potential choices for value of lambda. Say lambda equal to 0 is one possible choice. I will put this also because then the least square thing is a special case of ridge. So you pick a grid of values lambda equal to 0, 0.01, 0.02, etc. Say all the way up to 2.00, suppose. And I want to see which one is the best thing. Now I have my data set, which is like this. All the x things and the y things. I will split it up into a number of parts, say 5-fold cross validation, more or less equal parts, and I will say that this is my training part and this is my test part. So what I do is I will use ridge regression with all these different values of lambda and apply it only on the training part. So I will first take lambda equal to 0, apply ridge regression, get some fitted model, and then use that model to predict these things, the value of y based on the test part, and I will check how well I am doing. So I will get some predicted value y hat based on the case lambda equal to 0. I know the true values, so I will do a comparison. Now again I will go to lambda equal to 0.01. I will again do the same thing, 0.01. I will predict and then I will compare it with the true values. In this way I will get one comparison value. So I am just doing this square and sum and something like that. So I am reducing it to a single number. So I get a single number for each one of them. That is the cross-validation score. So this is CV lambda. For 0 I get one number, for 1 I get another number, and the way I have defined, the smaller the cross-validation score, the better. Then these things are closer. Of course, the entire thing is done with this as test and this as train. Then later I will make this the test part and these two things the training part. And I will do it again. So I get another set, I average over everything. So at the end of the day, I will get some cross-validation scores for each of the lambda. This is just a loop inside loop inside loop. Finally, I can plot them. And lm.reach function will show you the plot. So you have lambda and you have got the cross-validation score. Ideally, you should see something like this. And you will show, for this particular value of lambda, I see that I am getting the smallest CV score, that is, things are closest, so I should go for that lambda. That is the ideal situation. In practice, you rarely see this very beautiful thing. What you see is something like this. Initially some values, then up, down, up, down, up, down. And you have no way of knowing which one you should choose. And one of them may be down. Now the idea is you will say, well, this is the smallest, but this is far out and not much smaller than this. Naturally, that lambda is basically a perturbation. Ideally, you should work with this. You are merely perturbing it to achieve numerical stability. So this is like a perturbation. You do not want to perturb it too much. Small values of lambda should be favored. And this lot is more or less same. So choosing this lambda value is better. In many cases, the computer will also suggest some crude approximation to a standard error. So for each point, you will also get a standard error. As a result, you will get two other curves, one below and one above. So one standard error and one standard error below. And you typically pick that one which is the closest up to one standard error deviation. But all these things are just heuristics. Ideally, go for this one. Because this is definitely bad. All these things are more or less the same. Go for the smallest among them. This is the thing. How exactly you choose the value of lambda? There are different heuristics. None is actually better than others. So they're all comparable. So this is how you choose the value of a tuning parameter. The thing will be drastically different if you are working in a different setup. For ridge regression, I gave all these things, but what will remain the same is that you will split up your data into certain parts, use each of them as your test part in turn, making the remaining part training thing. You will choose a grid of values. If lambda is the degree of some polynomial, then you will take 1, 2, 3, 4, etc. up to some maximum degree. You will get such a plot and pick the lowest value or maybe the highest value depending on whether having a good value, having a large value here is good or a small value here is good. That will depend completely on that particular problem at hand. Now, various techniques that use this already built inside are, here are some of them. If you are using LARS, list angle regression, that uses cross-validation. Ridge, I have already mentioned. CART, C and RT, classification and regression tree, that also uses this. So all these things use this technique for choosing various tuning parameters. Okay, so basically that's the end of the lecture. Thank you.